Okay, so we are getting back into the book this week. We are going to pick up where we left off before spring break, which I know was a long, long time ago, and that's probably in our very distant memory of what we were doing. So let me refresh your memory. We were in chapter 9, which is all about probability, and we've already discussed section 9.1, which was on basic probability. How do you find a probability? What is probability? We talked about and probability statements and or probability statements. We talked about independent and dependent events. Those were the types of things that we talked about back in section 9.1. And if you've been following my webpage, I actually asked you guys to double check, make sure that you did that homework assignment that went with that section, and take a picture of it and send it to me. So if you've been following the assignments on the webpage, you have already double checked that assignment, done it, and sent it in to me. So what we're going to do today is we're going to continue from there where we left off, and we're going to talk about the next section, section 9.2 today. And that is on conditional probability. Conditional probability is a different kind of probability probably than you've ever looked at or done before. So this is probably going to be something new for everybody. Hopefully you have followed what the webpage has been asking you to do, and you have already read through the notes that I gave you. Hopefully you've already read through the examples that I gave you and kind of sort of figured it out. The reason I'm creating this video is to try to answer any questions that may still remain from what you've already looked at in the notes and in the textbook from the examples that I asked you to look at already. So if you look at the notes that I gave you, it starts by giving you a definition of conditional probability. It's the probability that an event B will occur given that another event A has already occurred. And it's written a certain way. So here's how we write a conditional probability. We still use that P to show probability. And it's the probability of event B given event A. So this is how you write a conditional probability. The second event B, that is really the event that you're looking for the probability for, gets listed first. The straight line here is a symbol for on the condition, a condition. Okay, so the probability of B given that, or in the condition that event A already occurred. So yes, this type of problem does have two events with it, event A and event B. However, the only event that you're really worried about as far as finding a probability for is event B, okay? And we're just assuming that event A already happened, which is basically, if you look at the second part of the notes, it kind of describes that. It says, this is different from a probability of multiple events with an and or an or. So before, back in section 9.1, we did do probabilities with multiple events, an event A and an event B. And usually it was either an and or an or. Find the probability of A and B, or find the probability of A or B. And we either multiplied if it was an and, or we added if it was an or. This is different, okay? This is a different kind of problem. And in the notes, it says it's different because you are only finding the probability of the second event, event B. You're just assuming that another certain event A has already occurred, okay? And this is how we write it. If you look at the very last sentence of your notes, it's probably the most important sentence in your notes. And you might want to star that or highlight it. It says the number on the bottom of your fraction, when you're setting up your probability for a conditional probability, the number on the bottom is how many things are in the condition. That's important to remember. So you want to make note of that. Whenever you set up a conditional probability problem, the probability of whatever you're looking for is what's going to go on the top. So whatever event B is, whatever you're looking for that probability of is what goes on the top of your fraction. What goes on the bottom of your fraction is how many things are in the condition, which is A. Okay, so whatever the condition is, event A, however many things are in that event is what goes on the bottom. The probability of what you're looking for is what goes on the top. Okay, now that's I've just kind of read through the notes. I know you guys have access to them. You can write them down yourself in your notebook if you want. You can just have them and reread through them as many times as you need to. Then underneath that, I asked you to look at examples 1, 3, and 4 in your books. These are charts and things like that are they're going to be difficult for me to put on a little board like this. So what I'm going to need you to do is I'm going to need you to kind of look in the book on your own. All I'm going to put on the board is just the work that goes with the examples. I'm not going to put the charts up. I'm not going to put even the question up. I'm just going to I'm expecting you to have your textbook in front of you. If you don't have that right now, you might want to go grab it real quick. You can pause this video, go grab your textbook, and find example 1, which actually begins on page 475. I'll write that on here. So we're looking on page 475 in our textbook, and we're looking at those 3 examples that I asked you to look at. We're going to look at example 1, 3, and 4. If you look at example 1, it's just kind of a basic, how do you do a conditional probability type of question. So it says, well, first of all, it gives you a chart. And it says a student committee is being formed to decide how after-school activities will be funded. The committee members are selected at random from current club members. The frequency table shows the current club membership data. So you have this table that has sophomores, juniors, and seniors. And then it has what clubs they're in: drama, science, art, and art. So there's your data. Again, I'm not going to put that on the board. You can look at that in the book. Then it says, what is the probability that a member of the art club selected at random is a junior? So here's how that is a conditional probability. What is the probability that a member of the art club? That's your condition. They have to be a member of the art club. And we're looking for the probability that a member of the art club selected at random is a junior. That's what the probability that you're looking for. So here's how you would write that. We're looking for the probability that the student selected is a junior, given that they are in the art club or a member of the art club. So you could write it like this. We're looking for the probability that we choose a student that's a junior, but we're assuming that we're picking from a member of the art club. So that's your condition, okay? So the way that you're going to, here, I'm going to put 475 example 1 here. So here's how your fraction is going to set up for your probability. On the top is going to be how many juniors you have. Now, it's not going to be juniors total though, because you're looking for the probability that you pick a junior, assuming that they are a member of the art club. That's your condition, is that you're picking from members of the art club. So what's going to go on the top is how many juniors that are in the art club. So look at your table, find juniors, and find art club. That's going to be 16. That's the number that goes on the top of your fraction. Now, what goes on the bottom, remember, go back to your notes. Most important line is the last line of your notes, which tells you that the number on the bottom is how many things in your condition. Well, your condition is that you're picking kids from the art club. So what's going to go on the bottom here is the total number of kids in the art club. Okay, so go find your art club column and add up all of the kids in the art club. That's going to be 24 plus 16 plus 18. Okay, so let's add those numbers up. 24 plus 16 plus 18. and we get 58. From there, you can reduce your fraction, you can change it into a decimal, you can change it into a percent. Quick refresher from section 9.1. Remember, whenever you're writing a probability, you can write it one of three ways: as a reduced fraction, as a decimal, or as a percent. Now, this is not reduced, so if you're going to leave it in fraction form, you do need to reduce that. That will divide by 2. So you could divide the top and the bottom by 2 here. And that'll give you 8/29. Final answer. Okay. And again, you could change it into a decimal or a percentage if you wanted to. If you're looking in the book, you'll notice that the book actually shows example 1 done 2 different ways. It has one method, which is the method that we just used. And then right below that, it gives you another method, and it gives you a formula for conditional probability. You can actually do all these examples that we're going to do together without using the formula for conditional probability. And if you look in your notes, you'll notice I didn't even give you that formula because it's not necessary. So if you want to learn the formula and use the formula in these problems, you can. But you really don't have to. If you do it the way that I just taught you and I just showed you, you can actually do all of the problems in that way. And in fact, example 3 is the same way. If you now flip over to page 477, and if you look at example 3, you'll see that in the directions for that problem, it tells you to use the conditional probability formula. But I just got done telling you that you don't need to use the conditional probability formula. And you don't. And if you look in your notes, you'll see that I drew a little arrow to example 3, and I told you to do it like a typical and probability. So you can actually do example 3 different from the way that the book does it. The book does it using a formula for conditional probability, but I'm telling you, you don't actually have to use the formula for that. So I am now on page 477, and I'm looking at example 3, and I am going to do it differently than the way that the book does it, okay? So it says, a band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that a surveyed student plans to attend the band's concert and is a fan of the group? Gee, that sounds an awful lot like a basic and probability question, just like we were doing right before you guys went on spring break when we started this chapter. And you can actually do it just like an and probability. So if you keep reading, yes, it says below that, it says use the conditional probability formula to find the combined probability. And it goes through all this formula and all this other stuff. You don't have to do it that way, okay? You can do it just like an and probability. So it says, what is the probability that a surveyed student plans to attend the band's concert? So let's write it like this. What's the probability that they plan to attend the band's concert and is a fan of the group? So we could write it like this. What is the probability that they attend the concert and they're a fan? Okay? Typical and probability. So if you remember how to do an and probability, then you should remember that an and probability means to multiply the two probabilities together. So we're going to multiply the probability that they attend the concert times the probability that they are a fan. So now you're going to look at your table of data, find the probability that they're going to attend, That's at the top. Students who plan to attend the concert. Okay, that's going to be your 70%. 70% of students plan to attend. Notice that when we write a value that is a percentage, we always change it into a decimal. So we need to change that 70% into its decimal form. Always change percentages into decimals when you're working with them. So we're going to write that as a 0.70. Now we're going to multiply that by the probability that they are a fan. Okay, that's going to be your 80%. 80% of the students who plan to attend are fans of the band. So we have 70% plan to attend times 80% who plan to attend who are fans. That's your 0.80. And then you can just multiply that together. So 0.70 times 0.80 is going to give you 0.56. And then you can change that into a percentage if you want. So you can either say 0.56 or you can say 56%. Okay, so yes, you can do it the way that the book does it and use the conditional probability formula, but you can also just do it this way too and just treat it like it's an and statement and multiply the two probabilities together. Okay, so let's flip to example 4 real quick. This is going to be page 478 in your book. Again, I'm assuming you need to be following along in your book with this video. If you're not, you're probably completely confused. So you've got to follow along in your book. We're on page 478, and we're looking at example 4. Okay, it says a marketer is looking at mobile phone statistics to help plan an online advertising campaign. She wants to find which product is most likely to be purchased after a related search. And so again, we have a table of data, different products, the percentage that of probability that they're going to do a search of that product, and then the probability that they are going to search and buy that product to the right. It says, find the probability a mobile phone customer buys given that they performed a related search. Now, again, it tells you to use the formula. It tells you to use the formula for conditional probability. You actually, again, can do this problem without using the formula if you do it the way that I showed you and that I taught you to do conditional probability. Just do it like this. You're going to have to, well, if you look right below that, you'll see where they set up another chart where they actually did the probability for each of those products. So you're going to have to do a conditional probability for each product. Product W, X, Y, and Z. Okay? And again, you don't have to use the formula. What you can do is just set up fractions for each one of these where you put the probability of what you're looking for on the top and the total probability of what is in the condition on the bottom. So the probability that somebody searched product W and bought it is 16%, which is 0.16. And it's going to be over, again, the number of things in the condition. Well, the condition is that they searched it. And the probability that they searched it is 46%, or 0.46. Here's the probability that they searched it and bought it. Here's the probability that they, in the condition, which is that they searched it to begin with. Okay? The condition is that they searched it. The probability that you're looking for is that they bought it. Okay? So the 0.16 goes on the top and the 0.46 goes on the bottom. Then you're just going to do the exact same thing for all of the rest of the products. Well, okay, so now we want to know, okay, well, what's the probability that they bought product X given that they searched it? Well, the probability that they bought it is 14%, which is 0.14, over what's in the condition. Well, the condition is that they searched it. The probability that they searched it is 32%, which is 0.32. Now do the same thing for Y. Probability that they bought Y is 0.12, 12% or 0.12, over the probability, the number of things in the condition. The condition is that they searched it. Well, the probability that they searched Y, product Y, is 35%. As a decimal, that's going to be a 0.35. Product Z, do the same thing. The probability that they bought product Z, given that they searched it, is 15% or 0.15 out of the probability that they searched it is 40% or 0.40. Okay, so this is how you would set up the conditional probabilities for each of these four products. All you need to do now is take your calculator and just start dividing each of these out. So 0.16 divided by 0.46. I'm just going to round that off. Well, I'll tell you what. Well, yeah, we will have to, yeah, let's round that off to 0.35. Okay, now let's do 0.14 divided by 0.32. I'm going to round that one off too to 0.44. Now let's round this one off. That'll round to 0.34. And then 0.15 divided by 0.40 is going to round to 0.38. Okay, so these are your probabilities for each of these four products. These are the probabilities that they bought given that they searched that product. So we can now see we're looking for the biggest number. The biggest number is this one right here. So product X has the highest probability of getting bought given that somebody searched it. Okay. Let me see if there's anything else that's important for us to talk about. Okay, yeah, I think that completes that example. It says, I know the book says, so product B. What it's really talking about is product X. Is probably a good choice for the online advertising campaign, it says. Why? Well, because it has the greatest chance of, if somebody searched it, it has the greatest chance of somebody actually buying that product. Okay, I can't think of anything else. What I want you guys to do is tomorrow, an assignment will be posted on the webpage for you guys to begin working on. Begin working on that assignment. Again, you can use the textbook for your resource. You can use the e-textbook. You can use this video. You can use Khan Academy. Some of you guys messaged me and said that you really liked the Khan Academy extra credit assignment at the beginning. That also has great lessons if you're still confused. So work on the assignment as you're working, or even now, if you have questions on any of these examples we just talked about, anything in the notes as you're working on the assignment, if you have any questions on any of the problems, email me. I can always do more of these short. I could do another shorter video, not one that's this long, but another shorter one just to talk about some specific problems if you guys have some specific problems that you want me to go over with you guys. All right, so I'm going to sign off for now. Let me know if you need anything. Just email me.